Hello guys, I'm back. Alright, so now I'm just going to talk about the setup here. I drew a map. So what's going to happen here is on the southern end of the low, there's going to be warmer air working into the region. Associated with the jet stream coming in from the Pacific. There's going to be an additional jet stream. There's going to be 2 jet streams in this area. So that's going to usher in some warmer ocean air into the south. Then on the north, you're going to have a cold front that's going to bring in the colder air, as I said, and then high pressure is going to build in and rotate more of that cold air down this way. And then what you get is you have really cold temperatures up here and then warmer temperatures down here, and you get a big temperature gradient in this thing that we call a baroclinic zone. Okay, so up in the blue here, you're going to have temperatures in the teens and the 20s. And then in the warmer air of this section, you're going to have temperatures in the 50s and the 60s. And then in the middle, it's 30s and 40s. But that's like a big change from the blue to the orange. That's huge. And that's important because cold air and warm air are different in density very greatly. So you're going to have a big density difference from the cold area to the warm area. And what that does is whenever you have 2 things that are imbalanced, obviously they're going to try to balance it out. So the densities are going to try to balance out, and that creates a lot of instability in the atmosphere. That's associated with the baroclinic zone, and our low pressure system is going to come in contact directly with this baroclinic zone as it moves through. And when it does that, you know, it's going to be absorbing moisture from the Gulf at first, and then moisture from the Atlantic when it moves east. That moisture is going to be what's used to try and balance out the density of the air. I'm pretty sure that's how you would explain that. And since there's such a steep temperature gradient, that precipitation is going to be very, very heavy at times. You know, not extremely heavy. It's going to be heavy at times though, because this temperature gradient is pretty strong. So, because you have the big temperature gradient, when the heavy band of snow forms, it's going to be on the northern side of the low pressure system. So the heavy snow is always going to be on the northern side. So that's why there's going to be a strip of 8 to 12 inches around here, and I'll get to that in a minute. But your heavy snow is going to be on the northern side of the low, on the southern part of the blue area, and the northern part of the purple area. Then you're going to get heavy wintry precipitation, mainly in the purple area where temperatures are a little warmer. So you'd have to look out for some freezing rain and some sleet, you know, in the middle part of the purple area, maybe the southern part as well. So, you know, Washington, D.C. on south is going to be fair game to get a pretty decent ice accumulation, as well as a minor snow accumulation. They're going to be mixing more. But then areas north of, areas north of Washington, D.C., along that line, along the arrow, they're mainly going to be heavy snow. Okay? So, this setup here is why there's going to be heavy precipitation. And I just want to reiterate something else. The low pressure itself is actually not that strong. It's really not. The reason that we're getting such a big snowstorm is because of the, you know, temperature gradient. That's one thing. The other thing is, you know, this system is going to be taking in so much moisture that it's just, and then the density needs to be balanced out, that it's just going to blow up basically because of the, you know, baroclinic zone here. So that's why it's going to be really heavy. So in terms of snowfall amounts, let's take a look at that in a minute. And I just want to reiterate that when the low is going east, it becomes negatively tilted, and that's why you're going to get moisture coming in from the Atlantic. Another thing I want to show you is our quantitative precipitation forecast. That tells us the amount of liquid we will receive from the storm, and we use this to forecast our snowfall amounts. So let's go here. Alright, so if you look really close, we're in like darker blue for that. That's a half to 3/4 of an inch of liquid. And you're like, what does that have to do with anything? Well, what we do is we take something called a snowfall ratio, and we multiply the snowfall ratio by the amount of liquid to to give. That's one way we get snowfall amounts. So if we're 1/2 an inch to 3/4 of an inch, and snowfall ratios, I believe, are going to be around 10. So that right there is about 6 to 8 inches. Maybe up to 9. However, that's a little lower than the amount of snow that I'm predicting, only because this quantitative precipitation forecast doesn't account for banding of the snow. If there are heavier bands of snow that are forming, that's going to produce additional accumulation. And when the low pressure is in this baroclinic zone, there's going to be something called frontogenesis going on. And that frontogenesis, as the temperature gradient steepens, is going to cause heavier bands of snow to form, again, on the north to northwest side of the low. And wherever that strip of heavier snow is, that's going to cause additional accumulation. Alright, so in the next video, I'm going to give my general snowfall amounts for the entire East Coast, and then I'm going to focus on you guys. Most of you guys are Long Island, New York City, will focus on that. Okay.